Today we will solve one example problem on consolidation. So, sandy silty this is your 1.8 meter, then this is water table is there 0.8 meter, gamma saturated is equal to 20.3 kilonewton per meter cube. This is 8 meter, soft dark brown clay, gamma saturated is equal to 17.9 kilonewton per meter cube, and at a depth 3.5 meter the soil has been collected. Now, this is a typical result of 1, 2, 3, 4, 5, this is 40, 80, 100 kPa. Now, it will start with 0, then this is 33.0, 15.6, 9.0, and then this is 5.8. Footing stress profile. Another part is given. This is your consolidation problem. Consolidation means set consolidation diagram is given. Now, E0 is equal to 1.20. Now, this is your PC E versus log P this is a 1.08, this is a 0.72. Now, the question is compute expected total settlement of footing now. This is a case where this footing is of size 3 meter by 3 meter. So, acted upon this footing is 11.50 kilonewton and the soil consists of first 1.8 meter is sandy silty soil and water table is located below the ground surface at 1.8 meter. This is your water table and gamma saturated is given. Then below 1.8 plus 0.8, below this entire depth is your 8 meter, total is your 8 meter, this depth is your 8 meter and it is a soft dark and brown clay and soil sample has taken at 3 meter from here, 3.5 meter from here. So, gamma saturated is equal to 17.9 kilonewton per meter cube. This has been soil sample has been taken here and this is given expected means earth pressure means sorry it is not earth pressure, this is P0 variation of P0 calculated or may it is given. Then footing stress profile, this is your footing stress profile below the footing, it is called delta P and this is your KPA, every 2 meter interval it is given. So, at the surface it is 52.3, at below 2 meter it is 22.1, then below 2 meter it is 11.6, then 2 meter it is 7.1, then 2 meter it is 4.7. Then the middle, at the middle this stress has been also given, at middle it is 33.0, here at middle at 15.6, here at middle is 9.0, here at middle is 5.8. Also the consolidation graph is given. With this consolidation graph E0 got it 1.20, PC also got it and for depth 6.1. How come depth has come 6.1? 3.5 plus 0.8, 4.3 plus 1.8. So, it will be 6.1, from here to here is 6.1. Liquid limit is 52.3, plasticity index is 23.8 and natural moisture content is 40.9% and gamma saturated is 17.9 kilonewton per meter cube. So, the question has been asked compute the expected settlement of footing because of your soft brown clay. Now, CC from correlation, CC 0.09009 into WL minus 10. So, which is equal to 0.38 E0 from graph 1.13. So, E0 is equal to WN GS. So, GS is equal to 1.13 by 0.409, which is equal to 2.76. Then taking a block diagram, this is a block diagram, V is equal to 1.13, Vs is equal to 1.0, Ws is equal to 2.76, and 1 plus 1.13, Wf is equal to 2.76 plus 1.13. Taking block diagram where Vs is equal to, assumption is volume of solid is equal to 1.0. So, from there you can calculate gamma saturated is equal to 1.13 plus 2.76 divided by 1 plus 1.13 into 9.807, which is equal to 17.9 kilonewton per meter cube. Now, what is this 1.13? 1.13 is your E0, E0 G plus E0 gamma saturated, G plus E0, G is equal to 2.76 by 1 plus E0 into gamma W. This is your gamma saturated. Now, once you get gamma saturated, you can find it out what is your effective stress overburden pressure, effective overburden pressure P0 prime, effective overburden pressure P0 prime. So, now this point and the y is equal to meter P0. So, this will be 1, 2, 3, 4, 5 and bottom. So, y is equal to 2.6 meter. We will start with this P0 effective stress 1.8, this will be 2.6, y is equal to 2.6. This layer has been divided into 5 parts. You see, from here we will start it. Now, at y is equal to 2.6, P0 is equal to 1.8 into 16.9 plus 0.8 into 20.3 minus 9.8, which is equal to 38.8 kPa. So, this is giving 1.8 into 16.9, then this water table is at below 1.8. So, it is coming 0.8 meter into, this is your gamma saturated. So, here it will be gamma submerged because water table is lying. Gamma submerged is equal to gamma saturated minus gamma water gamma W. So, 20.3 minus 9.8, this will give 38.8. Now, second point is your 3.6. So, it will be 38.8 plus 1 into 17.9 minus 9.8, which is equal to 46.9. Now, every 1 meter interval we are finding. Now, here from here to ground surface to here is 2.6 meter, then you go up to 1 meter. So, here it will be 3.6, this is your 1 meter 3.6. With this 3.6 we got it 38.8, 1 meter, this is your height meter 1 meter into 17.9 minus 9.8. If you look at here it is gamma saturated is given 17.9, then minus 9.8, it is your 46.9, then third part is your 5.6. So, it will be 46.9 plus 2 into 8.1, which is equal to 63.1. Then fourth is your 7.6. So, it will be 63.1. Similarly, you can calculate 2 into 8.1, which is equal to 79.3. These are all kPa's. So, fifth layer is 9.6, which is equal to 79.3 plus 2 into 8.1, which is equal to 95.5, and bottom is equal to 10.6. So, this will be 95.5 plus 1 into 8.1, which is equal to 103.6. So, these are the values effective overburden pressure P 0 prime, we got it point wise, it is given 1, 2, 3, 4, 5 bottom. So, if you look at here, this has been divided because this settlement has to calculated in this clay layer. So, this clay layer has been divided into 1 meter, 1 meter, 1 meter sub layers. So, for each 1 meter the P 0 has been calculated. P 0 is effective overburden pressure, or P 0 prime we write it effective. Once it is effective, it should be P 0 prime, and in this case also it will be P 0 prime. So, now the first calculation I have shown in detail. Now, the second, third, fourth, fifth as per this calculation has been made. Below water table it will be gamma submerged, above water table it will be gamma bulk. Now, once you get it, your P 0 effective overburden pressure versus depth, you can plot it there, and the plotting has been made there, effective overburden pressure versus your depth. This plot already I have shown. This plot has come from these calculations, Now, the second stage will be, once you get it E 0, first step is find it out E 0, Cc, then Gs, then gamma saturated. Here gamma saturated is not given at this point, gamma saturated initially it is not given. So, once you get it from here gamma saturated, we got it from this. This is your E 0, this is your E 0 plus Gs by 1 plus E 0 into gamma W, you will get your gamma saturated. Once you get the gamma saturated, the profile, all the profiles gamma saturated, and bottom of the soil is your clay is your gamma saturated, it is given, all the profiles has been given. So, effective overburden pressure P 0 prime you can calculate from here. So, this will be like, you see this is like this is the only unknown, gamma saturated, here it is the only unknown. So, which is required for calculation of P 0. This gamma saturated come from your E versus log P, from here you can calculate your Cc, E 0 you can calculate from here, Cc from your empirical correlation you can get it. Then once you get it, then you can find it out, E 0 is equal to Wn into Gs, natural moisture content is given, from there you find it out Gs. Once you get Gs, then you go for calculation of gamma saturated. Once you get gamma saturated, then you calculate your effective overburden pressure. So, this part is over of effective overburden pressure, layer wise we have calculated. Now, Cc prime is equal to Cc by 1 plus E 0, from there Cc prime is equal to 0.17. Now, you will calculate, obtain delta P, increase in stress. Increase in stress is already given below the footing, Now, it has been calculated based on Boseniuk's theory. It has been calculated based on Boseniuk's method, Boseniuk's methods. Boseniuk's method. Now, you can calculate the settlement. Here this is in tabular form, this is your point and this is your HI. So, this will be 1, 2, 3, 4, 5, then bottom, then HI, this is blank, this is 2 meter, this is again 2 meter, this is 2 meter, this is 2 meter and this will be blank. So, this is your P 0, then delta P, then xi 2, then delta H I. Now, first layer P 0 is we have already calculated 38.8, second is your already we have shown it 46.9, third is 63.1, 79.3, 95.5, then 103.6, then delta P is equal to 52.3, 33.0, it will be 15.6, then 9.0, 5.8, 4.7. This increase in stress due to Boseniuk's equation, Boseniuk's method, it has been calculated and shown here. For particularly here 2 meter, it has been shown here 52.3, then at the center it is 33, then at the center it is 15.6, then here at the center it is 9.0, then here at the center it is 5.8, then bottom it is 4.7. Now, xi 2 you can calculate, this is your strain C c prime log P 0 plus delta P by P 0. So, which is equal to 0.17 into log 38.8 plus 52.3 divided by 38.3, which is equal to 0.063. Now, xi 2 is equal to also 0.17 into log 46.9 plus 33.0 divided by 46.9, which is equal to 0.039. The typical calculation is given for xi 1, xi 2, xi 3, xi 4, xi 5, xi 6. If you look at here this strain, 1 means at point 1, first layer strain at point 1. So, it is C c prime log P 0 plus delta P by P 0. So, this will be 0.17 into log 38.8 and plus 52.3 divided by 38.3, this will be 0.063. Similarly, for xi 2 for second point 0.17 log, if you look at 46.9 plus 33.0. So, it will be 46.9, increase in stress is your 33.0 divided by 46.9. So, this will be P 0 prime plus delta P divided by P 0 prime. So, P 0 prime is 46, the P 0 prime is your in this case second case 46.9, that means increase in stress. First case it is 38.8, so it is 38.8. So, increase in stress by means of Boseniuk's, it is 52.3, it will be 52.3. So, now these values I have written 0.063, this is a typical calculation. So, 0.039, then 0.016, 0.008, then 0.004, then 0.003. Now, increase in means particularly change in height will come from your strain. So, this will be this minus this. So, it will be coming 0.078. Then this is coming 0.032, 0.016, 0.008, sorry, this delta H is coming, height h1 into xi 2 or xi. Delta h1 is equal to height h1 into xi 1. So, change in height delta h is equal to, what is your height? h1 is equal to, that is your 2 meter into xi 1. How much is your xi 1? 0.63. So, from there it is coming 0.078, 0.032, 0.016 and 0.008. Now, with this delta h I is equal to delta h, which is equal to 0.134 meter. This is nothing but delta h, change in height is nothing but, or change in, this is nothing but your total settlement. Total settlement, expected settlement is equal to 0.13 meter below the footing. So, this problem is a kind of solved one example problem, how the consolidation is going to be used for particularly settlement calculations. If you look at this consolidation particularly used for settlement calculations, initially this E versus change in height versus log P is given from this, because the soil sample has taken at a distance 3.5 meter below particularly this layer of soil. Once soil has been taken and consolidation test has been done, this graph obtained. With this graph, once again you can get it your E0 value. You can get it E0, as well as also you can find it out what is your also CC, you can get it, either you get it CC from here or you can get it CC from empirical correlation. So, here CC we got it from here. I have written earlier CC by means of empirical correlation. This you can get it also empirical correlation if it is not given 0.009 into WL minus 10. If this is not given, this E versus log P is not given, then you can get it here. If it is given, do not use, you can get it from your slope. This is called virgin curve. From the slope you can get it, what is your CC. Once you get CC, E0 you get it, then CC you got it. Once you got E0 and CC, you can find it out your G. You see, E0 is equal to Wn into Gs, specific Gs. So, this E0 you got it from here. Natural moisture content of the soil at this depth it is given, Wn is given. So, from there you can find it out Gs. So, Gs is coming 2.76. Once you get the Gs from here, then your next step is, initially the gamma is not given. Initially gamma saturated was not given. So, with this value E0, Gs, with this value you have to calculate your gamma saturated. So, then what is your gamma saturated? Your gamma saturated is equal to, this is your E0 plus Gs by 1 plus E0 into gamma W. This is your gamma saturated, you can calculate. Once you get your gamma saturated, this comes from particularly E0, G, gamma saturated, whatever the available data for this consolidation test from there, and CC, you can find it out consolidation. Once you get it gamma saturated, then find it out, second step is your find it out P0 prime, overburden pressure at this from here to here. So, that means P0 prime, I have shown the calculations particularly here, because this is a clay layer where this consolidation settlement is going to happen. So, this means this clay layer has been divided into equal number of layers of 1 meter, of 1 meter. with this 1 meter at this, what is your P0 prime? If you look at the calculation, P0 prime has been done. This is your particular this is above. This soil has no water table effect. So, that is why 1.8 into gamma 16.9, and below this 1.8 there is a water table. So, once water table is there, you have to use submerged unit weight. So, that means your gamma saturated is given 20.3. So, submerged is equal to gamma saturated minus gamma W. You calculate particularly this layer, this layer, this layer, and you proceed. So, this is a typical plot. I have shown this plot, variation of P0 versus the depth, how this effective overburden pressure is varying. Once you get effective overburden pressure, next step for settlement calculation, you have to find it out, increase in stress delta P. So, delta P, increase in stress delta P, from Boseniuk's theory you can get it, either Boseniuk's theory you can get it, or by means of 2:1 distribution, or by means of 2:1 distribution, 2:1 distribution you can get it. So, here because this is a load, point load acted upon this footing, Boseniuk's theory has been used to find it out, increase in stress because of footing in this clay layer, because consolidation settlement is going to occur in this clay layer. So, increase in stress because of footing in this clay layer. So, this has been calculated. So, every 2 meter interval, how much is your increase in stress? So, if this is the 2 meter interval, so increase in stress here 52.3, that means increase in stress here is 52.3, then 2 meter interval 22.1. So, we are going to calculate this settlement at the center of the layer. So, that means this is your 33.1. So, here it is going to be 11.6, then 22.1, and at the center it is 15.6, then another 2 meter it is 7.1, and here 11.6. So, it will be 9.0. So, last layer is your 4.7 and 7.1, at the center it is 5.8. Now, once you get the delta P increase in stress either from Boseniuk's method or by means of 2:1 distribution, then write it column wise. So, every 2 meter interval we got our increase in stress. So, this is not 1 meter interval, this is every 2 meter interval, because stress increase also we got it every 2 meter interval. So, you write it point 1, point 1 is at this point, this is your surface, you are writing at the point 1, not surface. This clay layer starts from 0.8 to this is your at here 0.8, here it will be 8 meter, total clay layer is 8 meter. So, this is your point 1 and this is your bottom. Now, point 1, height of the solid is 0 and P0 has been written 38.8 and delta P is written 52.3, and from there the strain has been calculated. So, the strain formula is Cc prime log P0 prime plus delta P by P0 prime. So, here you are getting 0.063. So, calculated 0.063. Next point is your point 2. If I mark it here, this is my point 1, this is my point 2, this is point 3, it will continue, and this is your bottom. So, point 2, particularly point 2, height is equal to 2 meter and P0 is equal to 46.9 whatever we calculated, and increase in stress delta P, if you look at here delta P, it is your 33.0, initially it is 52.3 at the surface, at the center it will be your 33.0. Now, from there you calculate your Xi 2. Then similarly your point 3 2 meter 63.1 15.6, all you calculate P0 and delta P, you just calculate 1 by 1. Then once you calculate P 0 delta P, then you calculate your Xi2, then find it out settlement. The settlement is nothing but your H1 into what is your strain. So, every cases H is equal to 2 meter. So, it is 2 into what is your change in strain. You can multiply, you can calculate your strain, calculate your settlement, then add it. So, total settlement, consolidation settlement will be 0.134 meter. So, this is one of these solved example problem. I just solve it. So, it may helpful particularly these assignments problems later on. One more problem I am giving this as an assignment, maybe student can practice, you can practice this one more problem as an assignment. So, you try at your home. This is a simple assignment problem. It is given P kilonewton per meter square versus void ratio, different void ratio from the laboratory. This value has been given. So, fast load, unload and reload. So, plot first E versus log P diagram, E versus log P. Once you get E versus log P, from there you find it out what is your CC, then CR, then you find it out PC. So, this kind of curve will come, E versus log P, this type of curve will come. Once you get it, then find it out your CC, slope of this, then find it out your CS, find it out your CR. Then once you get it, then find it out pre-consolidation pressure. From this curve you can find it out pre-consolidation pressure, and you do it in the graph paper and do it very neatly, so that you will get the appropriate result. You use your scale, proper scale, it will be E versus log P diagram. So, this is one assignment. So, try and do it. Once you do it, from there you can find it out what is your CC prime, CR prime, CS prime, that you can do it. Suppose this is E versus log P is there, from this diagram can you plot strain versus your log P, that you can think strain versus log P. If you can do, that would be fine. Thank you.